Oh, okay. That was a lot of claps. Okay. Hello, everyone. And the mic is good. People can hear me. I hope so. So I'll give you a bit of idea of who I am. So you know my name, work at AWS. I'm a solutions architect, and we have been. I get this question a lot. Is AWS present in New Zealand, or do you have any services developers here? Yes, we are here, and we have teams here as well. So I myself is an architect, and we have few people presenting today and tomorrow from AWS, and we have a booth outside. So come see us if you have any questions. And I have put a QR code if you want to connect with me later. So you can scan this QR code, connect with me on LinkedIn. And so I was asked to put this slide in here, but so it would not be possible without all the sponsors we have. And this is an amazing conference. This is the first time I'm attending OAPS Day, but yesterday I got to know that it has been running for a while. It has been here from since 2009, and John has been leading it from last 6 years. So amazing work John is doing and the team is doing, all the volunteers, and again the sponsors. Again, without them, this conference wouldn't happen. Okay, so what are we expecting from this session? It can be interactive, but again, I have so many slides, so we'll try to finish it, and we have questions in the end. So have you heard of AWS well-architected framework? Yeah, okay, few hands. And because you are in security conference, you might know what is API. Have you heard what is API? What is an application? Okay, again, yeah, more than well-architected. Cool. So I'll start from basics of what is AWS well-architected review, what is API, and then we will talk about how you can use the framework to secure your application. And if you feel like I'm talking too fast, just like say, yeah, talk slow. I'm all okay with it. And then we'll have few takeaways. If you don't remember all the tech I'm going to talk about today, the takeaway is the last slide that you will have to remember. Cool. So well-architected framework. So it is essentially, we created list of best practices that an organization can utilize. Previously, when we started, customers was asking like, how do I do it? What is the best way to do it? How can I secure it? Or how can I reliably do it? How can I get performance better? And then we started putting some questions, and that's when we introduced the pillars. And we have some design principle as part of the pillars. We put, it is in question format. It is not an audit, but there are questions responding to each pillar, and then you answer like, oh, are you using KMS or like any key encryption system? Or you say yes, okay, otherwise it's a high risk item. And then in the end, if it becomes a high risk item, then you get best practice recommendation. And so why you need it? To make sure that you build and deploy faster. You are not stuck around keeping the lights on. Then lower the mitigation, make informed decision, and learn the best practices. So this is not just like something that started now. We have been doing, as I said previously, customers were asking what is the best way of doing certain things. So we started this in 2012. Some nerd guy in AWS wrote a paper saying, okay, this is how you do it in best way. And then we realized, oh, it is actually quite popular. Many people are asking it. So we published it, and then multiple iterations. Today we have 6 pillars. We added sustainability a few years back, and we have, as part of the pillars, we have different lenses. So you come from Gen AI lens, you come from a SaaS lens, partner lens. So it is quite huge. Go check it out later. So pillars of well-architected. So we have operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability. And today's talk is going to focus on security pillar and how do you secure your application with the principles of security pillar and design principles. Okay, so security pillar compromises of security services, design principles, and implementation guide. Again, if you don't like reading like me, the 600-page is not going to help. So the implementation guide is pretty long. You can just look at design principles. There are 7 design principles, easy to manage, easy to talk about. And these are the design principles. So people look at security, and they see application, they see database, and they see lots of other factors. Or often, organizations don't even talk about security. They talk about application, feature releases, lots of other stuff. So having a strong foundation of security comes from very basics of what you do on an everyday basis. And that's when this design principles comes in picture, saying, oh, you start with strong identity foundations, you maintain and log all the traces of what is happening. You apply security at all layers. It's not just your applications, or infrastructure. You have to go deep, and I have a castle image in the end. So I'll show you the castle, that you have to save the castle. And what is the risk of that castle? So why we are talking even about security? To save something that is really important for your business. So it can be data, or it can be the business differentiator of yours. Protect data in transit and rest. Keep people away from data and prepare for security incidents. So I think they are all self-explanatory. It's not, this is one thing that I like, that they have not put acronyms over here. They have just put simple words for people to understand, so it's great. So as I previously mentioned, the first few slides are introductory to make people aware of what is design principle. So now, again, an introductory slide, or few slides where we'll talk about API, and then we'll go into design principles and security best practices. So what is an API? A little acronym, but anybody wants to answer? API?
Don't be shy.
Don't be shy.
Application programming interface?
Yes, application programming interface. And yeah, that's the first line. And I knew people will be shy, so I have to write it. So APIs, and okay, you have seen the slide, but does anybody wants to say what it does actually? It connects the apps together, okay. What does it mean in real world?
Data exchange between applications.
Sorry?
Data exchange between applications.
Data exchange between application, okay.
Yeah, it means we have a standardized interface between several applications. They may be working on different platforms in different parts of the world, but they have standardized way for them to communicate.
Yeah, standardized way to communicate. That's correct. So I think API is the last baby of the family who does not get many recognition that it should have get. So APIs is the way that the world connects. That is my definition. So without API, connecting the world together, or applications together, or your phone together would be so hard. So you can think of API as a waiter. a server. So you go to a restaurant, you put order, and if the waiter takes the order, give it to chef, chef cooks it, again give it to waiter, waiter sends it back to the customer. And that is API. You send a request to API, API send it to the app process it, do whatever magic it wants to do, and give it response back to the customer. And that is the simplest way of looking at APIs. It's a messenger, in short. So previously, I wanted to put an example of company X, but then I realized, okay, people will, I get sued for putting company X, so I put any company. So any app that you see, or any, if you, again, Facebook or any application, Uber as an example, like very simple. If you see Uber, you see Uber as a one app, but Uber is again connected of multiple building blocks or multiple puzzles. Puzzles would be a good idea. So a puzzle piece like looking at location, another puzzle piece can be like user management, another puzzle piece of rating, another puzzle piece, and each puzzle piece connects together, and the way where they connect is the API. And let's look at the example here. So again, shape of the puzzle. So each puzzle is different, each API is different, and the shape of the puzzle is the API definition, where again, to work, a rating app to work, you need user details, you need rider, driver, and stars they put. For login app to work, you need username and password. Again, for Uber to work, you need these APIs to connect together as a puzzle, as a whole puzzle. Now, if you think of APIs, and when I say it connects the world together, imagine the airline company. You asked, I want to travel from New Zealand to US, and you put your destination, you put the country you want to travel from, you put dates, and it gives you the details. That is, it took all the data and give you the details. Now, if you look at travel agency, the airline company has sent their details to the travel agency via an API. So when you go to a travel agency and say, oh, I want to travel from source to destination on this date, they will call the APIs of each airlines and get details from them. That is how the simplest of connecting the world. So companies now sell it as a product. There are consumers. And why it is a threat then? So if we look at real world example and people connecting, and then there are bad actors who might want to do something that can put your organization to risk, or your applications or APIs to risk. So we face some API challenges. So there is a broken user authentication is one of the common issue that we have seen, just because people are happy with admin username password, or a common Reddit password that I've always seen is Reddit, or admin123. So, and why would they do it? Anybody wants to say answer? Like, why would somebody try to impersonate somebody? To get some details, if they can impersonate, they can crack companies' data, they can ask for money, they can put it in public, so many things. And so impersonate is not as easy. If somebody impersonate or crack into the details, they are going to get all the details. There are other stuff that breaks it. For example, if you don't have login, right, logging enabled, then even if somebody impersonate and access your data without logging, you'll not even know that who did it. They can send botnet events. You don't have login, and within that botnet, they can do DDoS. We will have another slide to know what is DDoS. So once DDoS is in, okay, DDoS, it's an acronym. Anybody knows what is DDoS? Distributed denial of service. So with DDoS, when you get a request into, again, Uber, it's a one API call from one source. Imagine sending thousands of API calls from one location. If an application cannot recognize, then it's an issue. That how can one person can send 1,000 requests? So if they don't have any throttling, again, they can utilize the server, and it will keep people away who are genuine users. And then, again, rest of the stuff start. So it can put pressure on the business, and again, data breaches, and we see things on the headlines. So these are the common security challenges, and these are all put as part of API security challenges in OAP's top 10. And that's where we are here in the conference, to know about how we can look at these challenges and save it, and secure our organizations and applications and data. So these are the top 10 security challenges mentioned at OAP's top 10. It's all public link. Again, oaps.org, you can go there, find it. I have tried to put it into security domains for easy to understand, because again, each of them talks about various stuff. So broken access control can talk about your access can be broken at data level, at application level, at infrastructure level. So I tried to put it in various domains of identity and access management, application, data, infrastructure, and detection and incident response. These are the domains how teams are usually divided into an infrastructure. So this is an application team, this is a data team, this is the team who looks after authorizations and authentications, and then you have your SREs for detection and making sure that monitoring, observability is all there. And when you look at each domain, the OAP's top 10 are put it into various ways. So identity access management, again, talks about not pillar 1, it is security 1 of broken access control, security 7 of identity and access authentication failure, 2 talks about injection, S6, 7, and 10, 8, so many. Again, we'll talk about it in detail, so I don't want to take a lot of time here. Okay, so now the real talk starts. This was all basic and wanted to give you some introduction. So now we'll talk about each of the security domain and how we can utilize it to make sure that our applications are designed securely, and again, following the best practices of OAPs and well-architected review. So let's talk about first one, identity and access management using authentication and authorization mechanism. So best practice 1, identity and access. So identity is who you are, what you want to do, and why you want to do it. And to make sure that you are secure, you want to use appropriate authentication and authorization mechanism. You want to follow least privilege principles. You want to take advantage of smaller single-purpose microservices. Often companies are designed with large monolith, and that's how business used to work previously. Like you have a large server will put everything in. It is doing best it can, and then when any issue happens, that server is broken, and then you order another one, which can take again months and I don't know, weeks and months, and you get another one, you again fix it, install everything. Businesses can be down for a very long time if we looked at the previous ways. So example, Lambda function, where it does a single task. If you are asked to do login, it will just do the login part. If you are asked to do API rating, it will just do that. So next one is store your secret securely. It should not be under your laptop. It should not be in your like mobile password one that you shared with your wife and friends and everybody. So it should be secured and rotated often. Use multi-factor authentication and log failed logins and delay logins. So failed logins, somebody tried, for example, somebody tried to log in with my credentials and they got the A wrong. So, okay, they tried again and they got another one wrong. So when you get multiple authentications wrong, the server, the application should be able to look at and say, oh, this one guy is getting multiple authentication wrong. It can be an attacker as well, or somebody who impersonate as well. Okay, let's do something. Let's delay it, and you try again after 5 minutes, so that you don't just keep on trying the passwords. That also means the server, the backend server is free for just not trying one user. It can entertain other users as well. Okay. So as I said, securing resources with write access, understanding who can access and what they can access. So the responsibility is ours to identify that it is people. It is not machine who is trying to secure, and what they can access. So your employees, vendors, and application resources, they are all tasked to do certain things. But if they do something else, you should be able to look at it. So, okay, the floor is level 12 always, or level 13 always. This guy is going to level 10 now, or 14 now. Is this normal? They're trying to do something else? Okay, once they went, okay, it can be like just missed. If it happens again, why? Or one of the easy things that I have seen is that one of the service does guard duty is, if usually, I'll give you an example actually, that would be easy. My customer called me and said, oh, we have a threat. I was like, why? And so guard duty detected and said that usually your developers log in from New Zealand time zone and log into this particular machine. Guard duty detected and said, oh, somebody is logging not from New Zealand and different time zone at 3 a.m. And I was like, okay, did you call the developer and ask? And he said, yeah, no, maybe. So he called the developer and asked, like, why did you log in? Oh, I was free, and I did not have anything else to do, so I was just patching and doing stuff. It's like, oh, no. You just created a threat for the entire organization. So it can be genuine as well, but the good part is at least it was detected, and people were able to do something after that. Most often when you look at security and you have amazing setup where if somebody joins, you have right authorization, and you make sure that people are intended to do the certain job and they don't do something else, like they don't log in into different account or different applications. And you set and forget, but please don't do that. Don't set and forget. Reiteratively look at them and see if the person still needs the access or not. Or did they change the job role? So continuously monitor, continuously verify, and reanalyze the permissions they get. So that is all about authentication. And again, last takeaway of how do you manage authentication? You choose strong sign-in mechanism. You use temporary credentials for your machine. You store and save, use your secrets securely where it can be automatically rotates for your application, and it relies on some identity provider. You audit and rotate again credentials periodically and leverage groups and attributes so that you have one set of users who are required to do, like, for example, QAs, testers are required to do one set of jobs so they can get access to particular thing. You don't have to manually do for each QA or tester. So next is manage authorization. Define the access requirement, grant least privilege. Least privilege is often what I see, again, a baby that did not get much recognition. When somebody joins, you give them admin. Okay, you are an admin and you get full admin access to all our stuff. Okay. Maybe you don't need it. Maybe he just needs a reader access. So the best way of doing it, you have groups defined. If you are a tester, you need access to just dev resources, QA resources, and your production is sitting somewhere else in some other account. If you are a developer, you need access to development account or max QA account as a read-only access. If you are an architect, you might want to oversee all of that. If you are an auditor, you only want access to your audit account. You don't want access to everything. Then manage access based on, again, rotate it periodically, and again, make sure that you look at the access and where it is secured. Cool. Next, application security. Application security is all about enabling your people and making sure that they are equipped with the right things to do. So train the people, collect the technical and business requirements, and follow secure coding practices. Oops. I clicked twice. So when you talk about application security, often I've seen is it is done at a very security is looked as a blocker, not enabler. It is often seen as, oh, if I want to do this, it might block my work. I'll not be able to do it rightly. So you have to first train the developers and train yourself if you are a developer that how can I make things secure? How can I automate through the testing throughout the development and the life cycle, release life cycle? Then again, perform regular pen testing. So yesterday, somebody told me, like, pen testing is so expensive. We don't want to do it. Okay, I would say do it, and it might be expensive if you ask them to do everything. Within your team, you should be, within your development cycle, you should be able to realize that what are the threats for your business, what do you want to achieve out of that pen testing, and then tell the pen testers, it will save your time and their time and money. There are certain things that you will be able to test yourself, so you don't have to get a tester from outside to test those repetitive stuff again. And then manual code reviews. Finally, automation is good, but again, a second pair of eyes, human eyes, can help to do code reviews. So it should be a continuous and centralized way of developing your softwares and programs, and then again, regularly access it, and build a program that embeds security. And I will talk about security ownership in the end to talk about, like, how it is not just one person or security team's job, it is everyone's job. Next is data encryption and integrity. So I will try to run a bit fast because we might run over time. And we are at only third practice now. Okay. Data encryption and integrity. Can somebody tell me like why this is important, or is this even important?
It helps us also applying security in that, for example, if some of the controls we have protecting data fail, and someone actually acquires the data will not be usable to them without the keys to encryption.
Yes. So I think this is the most important one. So others are important as well, but this is the most important one. Even if somebody takes your data, they will not be able to utilize it, see it without your keys. So one of the code that was mentioned by Werner was store like nobody is watching, but encrypt like everybody is. So there are encryption mechanisms that are available widely used. Okay, if we get quantum, it's a different story, but right now what we have is various encryption mechanisms that are the only ways right now we have to secure the data and use encryption extensively. So you want to encrypt it and protect your data in transit and at rest. I want to really stress this thing that in transit and at rest. It's not like you encrypt it once and then don't do another one. You have to do both to make sure that the data is flowing right way. And this is something that if I say it right now, and marketing would hate me, but if you don't want to keep any PII data if you don't need it. So store what you actually need. If you don't need something, don't store it, and then it is not your headache. If you see, often people collect names and all other PII data that you don't want it as part of your application. Don't collect it. That will minimize at least some part of your security. So data classification is really important. Classify your data. Make sure that you are storing sensitive data separately to your normal data. Then define protection control, mask your data, and it should be an automatic process. For example, like in AWS world, again, Azure world or any other world, it might have different stuff, but again, cloud works the same way, and different applications, different services, just naming convention. So mask your data. We have something called Macy, where it can find out if this is a sensitive data, and it can notify you that there is sensitive data in one of your buckets. And you can then again automatically identify, classify, and protect that data. Then also, lastly, have a data lifecycle management. If you don't need that data after a certain time, just purge it. Don't keep it. Don't store it for a long time. Again, protect your data at rest. There should be some automated ways of protecting it, enforcing encryption. So for example, again in AWS world, you can create automated life cycles when if somebody create a VM without an encrypted storage, it will notify and delete the VM. So that even if some developer has access to create a VM without encryption, the automation will delete it. And they can come to you and ask, like, what's wrong? I'm not able to create a VM. And then you can tell them, like, this is the way to do it. Protect data in transit. So enforcing encryption in transit, having secure authentication, TLS, to make sure that each data that is traveling is secure. Keep people away from data. You don't want to have direct access. You don't want to store something and then you have to grant that access. Just put version controls, put each operation as a code. Okay, now Second last, infrastructure protection and DDoS. So told you we'll talk about DDoS for sure. So as part of infrastructure protection, we have 4 topics: DDoS, throttling and rate limiting that I already briefly introduced, network boundaries, and compute protection. So DDoS, we have again, our pretty any company, they do amazing job, and then there is an attacker who just keeps on sending the malicious request, and then the server is blocked because they can't serve genuine users, and that puts your application to risk. And this is how you see it in the end, that the website is not able, it cannot be reached, it shows different errors. And what is happening in the backend? The attackers use bots, sends multiple requests to the target, and the target, the CPU or like the API consumption of it is so blocked that it cannot use any other new request. So how you can save it? Use edge locations, CDNs, because they are designed to scale and identify DDoS. Protect your DNS, protect your origins, and again, you have a scalable architecture. So even if somebody sends DDoS, your infrastructure should be able to scale. By the time it scales, it should not also scale to infinity that then you get like a bill in the end. So it should scale to a certain limit, just to give you a breathing room to identify a DDoS and break it. Protect your network resources by having different layers. I'll talk about the layers, and again, implement inspection and protection. Protect your compute resources, regularly patch your resources, enable people to do things from distance. So it looks like apply security at all layers. So imagine you have an app user who wants to use your app. So you have first DDoS protection, then you are doing a web filtering, then you are encrypting at transit, then you are able to do some routing and again throttling. Then you have firewall at your application level, and then again for your data, you have access and authorization of who can access and what they can access. So people, for an app, there are multiple, for a bot to crack it, there are multiple layers to crack the data layer in the end. So last one, threat detection and incident response. Now, we have a threat. What do? We try to secure our data, network, compute, infra, everything. Now we have got a threat. So to recover the threat, you have to have a plan. It's usually called incident response plan or a runbook or a playbook. And recently I spoke to somebody in an organization, and I asked, do you have a runbook? And they're like, what is runbook? Okay. Do you have a plan if attack happens? What can you do? Oh, we have a person who knows everything. I was like, okay, and what if the person is sick? Oh, he is so good, he doesn't get sick. He has not taken a single sick leave. I was like, okay, what happens if it happens at night? Oh, he comes to office like late at night as well. So he should be good. I was like, okay, you are in serious trouble now. And I was like, okay, what if the person leaves the organization? And that's when he started thinking, oh, now it is a real problem. And then they started thinking of, okay, I need to put an incident response plan. I need to have some controls where by doing drills, it's like, a fire drill we used to have in our offices. Just do a fire drill in your cloud world or or on-prem world, wherever you are, and just switch off one server and see what happens. Do it in dev first. Don't do it in production. And see what happens. And then you can start creating some response plan and actually tell your tell your leaders that we need it. And that's how you get a buy-in. So again, a plan could look like this, where if a user activity happens, how they will get it and how you secure it at each layer. So make sure you have logging and monitoring, again, incident response plan. Okay, so to get incident response plan, you need to first identify who are the key person to talk to if something happens. Is it the security team? It cannot be the only security team. It has to be all levels of coming from your leaders of the organization to down to the developer. So who's the SRE team lead? Who is the data lead? Who is the infra lead? Who is the application lead? And again, all of these lead, who does it report to? Because any big thing happen, your leaders wants to know. So identify the key persons, internal and external. So you might be using some SaaS application. So you want to know if that SaaS application, we all know the CrowdStrike issue. So you should be able to identify it. Develop a plan, prepare forensics capability, where you know if something happens, like you will be able to identify the root cause by checking CloudTrail logs or some way of checking your applications and API calls that are happening in between. And pre-provision access is usually the backdoor. And I have 2 minutes left. Okay, run simulation events like the way I mentioned, do fire drills. On your dev environment, okay, if somebody comes in and say, I said doing drills, I just said doing drills on dev environment. So usually the suboptimal security, the reason is you don't have we have lack of visibility, we don't have enough people, and we are not able to prioritize. So it is all because, again, the leaders don't have, the people don't see security as the first thing. So in AWS, what we do is the service team owns the security of what they develop, and the security team are usually the enablers, and they oversee the security. So they are not like, if you see Amazon, we have like so many services, so many business units. If we are going to do, the security team is going to look at each and every feature that is launched, it's not possible. So if you develop it, you own the security of it. So as I said, we will have a castle. So this is first looking at layers of defense in depth, policies and procedures, network and edge protection, identity and access management, threat detection and response, infrastructure protection, application protection, and finally, you save the crown of data protection. And finally, that is the takeaway. If you don't take anything from this today, take this, that how you will look at apply security at all layers. And finally, I want all you to read this. Werner Vogels is our CTO, and he said, protecting our customers should be our #1 priority. At AWS, security is our #1 priority. We take security very seriously, and without that, we don't have any business, or nobody has a business if we don't take security priority. Cool, and that is it. Oops. Thank you.
Thank you very much.
Thank you.